Okay, let's discuss virtual functions. A virtual function is a member function which is declared within a base class and is overridden in the derived class. Using virtual functions, we can make sure that the function used in the base class does not work in a similar way in the derived class or derived classes. Function which has to be declared virtual should have the keyword virtual in the beginning. So let's say, why do we need virtual functions? Why not solve the problem using just class pointers? Suppose if we want to use a class pointer to point to the objects of different classes. So we create a class pointer and point it to the base class that refers to all the derived classes. But as the pointer contains the address of the derived class, it always executes the function in the base class. And so the same function in the derived class is ignored by the class pointer. So to solve the problem, let's say if we want to execute a specific function in the derived class of the same name as in the base class, then we would need to use virtual functions. So the above problem can only be solved with the use of virtual functions. Now let us see the implementation of virtual functions. Let us clearly understand how virtual functions work and what are their advantages with implementation in C++. Let's get started. Okay, now let's see the implementation of virtual functions. Let me include the header file with standard C++.h using namespace std. Let me create a class named b, which signifies the base class. Now let me have just a single variable for simplicity. Let me say int a. Now a function void display message, and the definition would be just to see out that derived class function called. Now let me create a derived class for the same. Let me create two derived classes for simplicity. Let me say d1 and it inherits d class b. Okay, under the public access specifier, let me say for simplicity we have int b and the same function void display message but different definition. So, and that should be base class and this should be derived class 1 function called. Let me go ahead and create another derived class b2 which also inherits class b, and inside the public access specifier let me have b and the same function void a message but again with different definition. Derived class 2 function called. Okay, so we have three classes. One is the base class, two are the derived classes, and they all have the same function but with specific definitions. So class B has its definition of its own, class D1 has its definition of its own, class D2 has its definition of. But if we use class pointers and point to any of the derived class objects, then also the display message uh, will be used in the base class. So that is to say that if we say if I created an object of D1 and use a base class pointer to point to the object of D1 and call this function, this would be executed and not this. So let's see how. Inside the main function, let me create an object of class D1, D1 obj1. Let me create a base class pointer or class pointer which points towards the class B. So let me say B and name of the pointer is ptr. Let me assign the object address of obj1. Yeah, j1. Now let me use the function of display message of object obj1 using member access operator. So let's see the output now. I've clicked on the output and see we have, even if I've declared the object for the derived class d1 and using the function display message will show me the outputs or the output which is executed in the base class. This gets executed, but this never gets. And to solve such problem, we need to use virtual functions. So we need to declare this function virtual in order to now use any of the specific functions we want, all having the same name. Let us say I want to use this function for displaying message derived and to print derived class 2 function. So to do this, I need to first declare an object of class b2, let me say obj2, and now using the pointer to the base class or the class pointer which points to class b, I can assign the address of obj2. Now if I use the member access operator for the ATR, now I can use display message function. Now you will be able to see this and not this because this function now has been declared virtual. Let us see the output now. Yeah, so derived class 1 function called, derived class 2 function called. This is because I've also assigned first the address of obj1 class d1 use the member access operator. So this was executed. Then I assigned the address of obj2 of class d2. Then use the member access operator. So this gets executed. These are some of the advantages of virtual functions. That's it about this video. Thank you.